Hello everyone, this is team number 8. We are going to talk about our project titled A Data Mining-Based Approach to Forecast Energy Efficiency in Buildings. Building sector is responsible for almost one-third of energy consumption and 15% of direct CO2 emissions worldwide. Therefore, there is an urgent call to go toward energy-efficient buildings. Considering smart buildings as a solution, characterizing, modeling, and forecasting the energy consumption of buildings is crucial. Accurate modeling and forecasting of building energy demands enables numerous energy management and efficiency applications such as informing earlier stage design decisions, estimating improvement to building energy performance, optimizing building HVAC systems, and urban energy infrastructure planning.
Building operational and its indoor and outdoor environmental parameters characterize the building energy use. Sensor-based approach using machine learning is one of the most effective methods for building energy forecasting. However, there are some knowledge gaps in this field. The first one, accurate load forecasting method, considering different kinds of machine learning algorithms. The second one, effectiveness of the prediction algorithm on various spatial and temporal data scales. So the primary goals of this project is to employ data mining techniques to predict the energy usage at the building zone and floor level. There are three main objectives in this project. The first one, understanding of correlation between energy consumption and indoor and outdoor conditions. And the second one is load prediction, obtaining an accurate model to predict the energy consumption of the lighting, the plug, and the air conditioning unit of the building zone. And finally, examining spatial and time resolution effect on the load forecasting accuracy.
Our first objective, which sometimes is considered as pre-modeling step, is an extensive investigation of correlations between our attributes. To achieve this goal, we can develop a correlation matrix using Pearson correlation coefficients, which is a very common measure of correlations for numerical attributes. It will allow us to identify the key attributes and remove all attributes showing little correlations. Our second target, which is our main target, is load prediction or forecasting three categories of energy consumption based on environmental condition. In literature, we found that ANN and SVM are the most common methods for load prediction, and we are gonna implement them. Subsequently, the performance and errors of these models will be compared.
Here we have our third objective, which is investigating effects of spatial and temporal granularity and the power of our load prediction model. For this purpose, first we prepare the dataset at related temporal and spatial levels. This granulation changes from bottom to top like a pyramid, as shown in the figure. For spatial resolution, we consider zone level and floor level, and for time resolution, we try to consider hourly, daily, and weekly intervals. Then we apply two different potential ML models, which could be ANN, artificial neural network, and support vector machine, that are applicable for our context, which is modeling a numerical dataset for sensor-based energy prediction. And finally, we compare the power and accuracy of our models for different spatial and time granularity.
Our dataset is for a 7-story building in Thailand and includes the electricity consumption for plug lighting and air handling units in each room of each floor. Indoor conditions are also gathered at each room by sensors. Originally, the dataset has 30 attributes and 400,000 examples. Moreover, outdoor conditions are added to the dataset from another source. Last but not least, more than 19% of examples are without missing values. In this figure, the variation in AC unit load versus indoor and outdoor condition is shown in a week. When the AC unit, the blue lines, start working, indoor temperature and relative humidity reduce, and conversely, when the AC is turned off, indoor temperature and relative humidity increase. This trend confirms the validity of our dataset.
Our main dataset for floor 6 has 400,000 samples and 30 features. In order to clean the data, first of all, we had to change the type of a date column into date time. Also, we need to delete the first 3 months of the data because it has so many missing values. Also, we filter out the working hours from 8 a.m. to 5 p.m. and we fill the other missing values with the mean value of that column. Then we have a dataset with 120,000 samples. Then we zoom into zone 1. We can see the box plot of zone 1. It shows some outliers that should be detected and excluded in the further analysis. Here we can see the correlation between different attributes of a zone 1, which shows a very strong correlation between zone 1 light and zone 1 illumination, and also we can see the distribution of the data for the zone 1. For next step, we need to clean all the data. We need to insert other attributes such as temperature and humidity to our data, and also we need to compare different classification models, and in final step, we have to evaluate our model.